Hello and welcome to my channel, Rhino here. Today I'm doing part 2 of Mike Riddle supposedly giving evidence for God's existence. You might want to watch part 1 if you haven't yet, they do tie into each other, but just a quick recap. The last argument that Mike made was basically that the universe can't be an infinite number of years old because then we'd already be at maximum entropy. So let's see what's next.
After maybe 1 trillion years, all the stars in this universe would have burned up all their energy and there should be no stars left.
Assuming that the universe has always been as we see it today, which we know is not the case. Here we go again with creationists assuming that conditions are always the same despite evidence to the contrary, and then at the same time turning around and accusing scientists of not being aware that conditions change.
That's a good illustration of what would happen if this universe had no beginning. It was infinite. All the stars would be gone. So what do the non-believers do about this? Well, they give us a challenge. The challenge is new stars are forming all the time.
What? That's not the solution to how the universe could be infinite. I mean, it's true, we do see new stars forming, but if the universe were the size that we see it now for an eternity, then all the gases that condense to form these new stars would also have been used up. So that's not even close to an argument for an eternal universe.
Well, is this actually true? Well, I do read that in the textbooks, but the question is, has anybody ever observed this? And does that statement, new stars are forming all the time, really agree with science?
No, we have not directly observed a star forming, and yes, new star formation really does agree with science. A good analogy I've heard is to picture an alien race that's studying humanity from orbit. They only have one day to do it, though, so they see humans in every stage of development, from infant to elderly, but they never actually observe a human being born. Would they then be accurate in concluding that humans don't reproduce just because they never witness a birth? I mean, they can see every stage of development, but the birthing process usually takes place under a roof, so in their one day of study, the odds of them seeing an outdoor birth are extremely low. But they see newborns being brought home from the hospital, they see toddlers, older children, teenagers, young adults, middle-aged people, the elderly, they even see some people die. They can conclude from their observations that we do indeed reproduce, even though they never directly observe it. It's the same with stars. We see stars in all stages of their development, from congealing gas clouds to supernova remnants of long-dead stars. Astronomers can then piece together the life cycles of the stars, from birth to death. There are competing hypotheses about the specifics of how stars form, but it is undeniable that they do in fact form, and saying that they don't just because we've never seen it is like saying that humans don't reproduce because you've never seen the birthing process.
Well, what we have found out, and what we know, based on observable and repeatable evidence, folks, is that stars really will not form by naturalistic processes.
What's your source for that statement? Which paper concluded that stars can't possibly form naturally?
Well, how is it done, according to the evolutionists? Well, we get these gas and dust clouds that rotate round and around in outer space. They just go rotating around and around. As they rotate around and around, they begin to gravitationally collapse inward due to the rotation and get so dense they form a new star.
Close enough. As is usually the case with creationist interpretations of scientific processes, there is quite a bit more to it than that, but that'll do for now.
But folks, that does not agree with science. It might agree with evolution possibilities or evolution philosophy, but it does not agree with real science.
Well, sorry, but biological evolution really has nothing to do with star formation, so I guess you're right. Nothing about the formation of stars agrees with the theory of evolution, because the theory of evolution doesn't even attempt to explain star formation. You could call it stellar evolution if you like, but that doesn't somehow magically make it not science.
Let me read you some quotes from scientists.
Yay, quote mine time!
Dr. Jason Lyle, who has his PhD in astrophysics, makes this statement. Star formation is problematic at best. Gas is very resistant to being compressed. However, in a typical nebula, the gas pressure far exceeds the minuscule force of gravity.
This one goes deep, get ready! Jason Lyle is a rare breed indeed. He is someone who not only holds a PhD in a relevant subject, and not only has published multiple times in reputable journals, but has also been a young Earth creationist through the whole process. which is odd given the frequent creationist claim that creationists are discriminated against in the scientific community. It seems that when they do good work, they do get published. But his published work all revolves around subjects that have nothing to do with the age of the universe, usually covering convection cells in the sun. So this guy is actually qualified to speak on astronomy. But here's where it starts to get interesting. I looked up the article that you pulled that quote from. There is a source listed for the statement that the star formation is problematic at best. Upon looking up that paper, which is available for free thankfully, it turns out that the problem is that we have several hypotheses about how stars form, but until we get an orbital interferometer, we have no way of determining which hypothesis is correct. The paper basically details all the information we could collect about star formation if we had an orbital interferometer, and shows the problems with ground-based observatories. It says nothing about there being an actual problem with the formation of stars, so Dr. Lisle seems to be relying on people not reading past the title in his own reference, which could leave a misleading impression if read in the wrong context. Rather notably, there is no citation for the claim that the gas pressure would exceed the force of gravity, so that just looks like a baseless assertion at the moment. But what I found most interesting is that the sentence following the bit about gas pressure is the claim that secular astronomers believe that external forces, such as a shockwave from an exploding star, are necessary in most cases for star formation. This has citation number 4, which is my favorite citation from the entire article. Here's what citation 4 says. But, of course, this would require a previous star, and so it cannot be used to explain the formation of the first stars. So his citation for the shockwave formation model of stars is, the idea that a shockwave from a dying star can't be there unless there was first a star. What a wonderful source. It's like he thinks he's the first astronomer to ever realize that for there to be a shockwave from a dying star, there must first have been a star. Nobody's ever considered that until now. Wow, how profound! Of course, that's one way that stars can form, but it's not the only way. I know Mike is a fan of fuzzy words, so let's examine that statement. External forces, such as a shockwave from an exploding star, are necessary in most cases for star formation. I'm not sure about it being necessary in most cases, as every page I've read about star formation neglects to mention needing anything other than gravity, but even if most cases of star formation need the shockwave, that means that some don't. And given the extremely large size of the universe, even if a tiny percentage of stars don't need a shockwave to form, that would have been enough to provide the shockwaves for the rest that did form with their help. Remember the antimatter to matter ratio from part 1? For every 10 billion antiparticles, you got 10 billion and 1 particles? That's a tiny difference. 1/1,000,000th of 1% difference. If I counted my zeros right, that is. And that tiny difference resulted in enough matter to make this huge universe. So all it would take would be a few stars forming without shockwaves, and that would produce enough shockwaves to take care of the rest. And that's assuming that Dr. Lisle was correct about needing a shockwave in most cases, which seems to be a rather dubious claim. And for clarification, I know that shockwaves can induce star formation. My problem is not with that idea, that my problem is with the claim that they are needed in most cases.
Well, let's turn to Scientific American, not a Christian journal.
Also not a scientific journal in general. It's a popular science publication. A pretty awesome one to be sure, but it's hardly the definitive source for anything that it reports on.
And we read this. Once a protostar reaches a threshold of about 20 solar masses, the pressure exerted by its radiation should overpower gravity and prevent it from growing any bigger. In addition to the radiation pressure, the winds that so massive a star generates disperse its natal cloud, further limiting its growth as well as interfering with the formation of nearby stars.
So upon reading the article that this quote is from, I found that it was taken out of context. Shocking, I know. Remember, Mike here is trying to convince us that the universe has to be young because stars still exist and we've never actually observed the formation of a star. This is his first scientific source that he has used to support this idea. But I found that what this part of the article was talking about was specifically massive stars, which in astronomy are stars of at least 10 solar masses or more, but this article is talking about ones that are 20 times the mass of the Sun. The problem of pressure being exerted by the radiation of a protostar pushing gases out harder than gravity pulls them in only shows up at about 20 solar masses. And if you kept reading the article, we find the following solution for this problem. A massive star is able to reach a seemingly impossible size because it does not grow uniformly. Radiation emitted by the protostar pushes gas away, creating giant voids, bubbles, within the gas, but does not completely choke off the inward flow of gas because the material collects into filaments in the interstices of these voids. So it looks rather like you just stopped reading after the paragraph where the author summarized the problem instead of continuing to read to where he offered the solution to the problem. Fun fact, this filament model suggesting that this is how massive stars are formed had only been done in computer simulations at the time the article was written. This is an example of a scientific prediction. In the paper that the National Geographic author cited, they predicted that this is how we would find massive stars forming. This paper was published in Science in 2009, and then in 2013 astronomers confirmed these predictions with observations. This is the difference between the ad hoc explanations that creationists come up with and the predictions that scientists make. Scientists plug their data into a computer model, study the results, and then concluded that if their data is accurate and correct, this is what we should observe in the real world. Then, 4 years later, it was observed in the real world. Creationists, on the other hand, are bound to what the Bible says, so rather than making predictions, as most if not all of the scientific predictions made in the Bible are wrong, they are forced to come up with explanations that make the data superficially appear to agree with them. But even when it does seem to line up, this is usually a case of the creationists taking the scientists out of context.
And let's continue. John Hartnett, PhD in physics, makes this statement. Without something else, the outward pressure due to kinetic energy of the gas molecules in the cloud is so much greater than the inward pressure due to the mutual gravitational attraction of the cloud that the resulting net outward pressure would cause the gas cloud to disperse rather than collapse.
Here's a fun fact for you. While researching the last quote, the only time I found anyone mentioning a problem with gas pressure overwhelming the force of gravity was with the formation of massive stars. It doesn't seem to be an issue with smaller stars. Also, upon looking up John Hartnett, I found that while he is a genuine bona fide physicist, he specializes in ultra-stable cryo-cooled sapphire oscillators, which is a fancy way of saying sapphire atomic clocks. While I'm sure the work he does in his specialized field is excellent, knowing a lot about atomic clocks does not necessarily translate to being an authority on stellar development. With science nowadays, scientists are becoming more and more specialized with less overlap between the fields, meaning that dabblers like myself rarely accomplish anything significant because most of the things that could be discovered without spending years researching a very specific field have already been discovered. I'm sure there is more out there that backyard scientists will discover, but with every new discovery that becomes less and less likely. It's not like in the early days of science. In fact, I have a book that lists several of the most important scientific experiments in history. The first one is something that every kid does in the bathtub: push an upside-down cup underwater and watch as the water fails to fill the cup. This was, at one point, a groundbreaking experiment which helped with the discovery that air is actually a physical substance. Empedocles, who made the discovery, would definitely have had to have been more scientifically minded than your average Joe at the time in order to realize the significance, but he didn't need to specialize in the study of water to a point where he literally had no time in his life left to study any other subject. And such is my problem with this quote. When you ask an astrophysicist who studies stellar nurseries about it, there will definitely be some "we don't quite know yet" answers. But they don't make rookie mistakes like citing a problem in the formation of massive stars as if it's a problem in the formation of any stars.
And finally, from Science Journal, we read this. We don't understand how a single star forms, yet we want to understand how 10 billion stars form?
Okay, so I'm writing this part of my script before reading the article, as it's behind a paywall, so I have to do some finagling before I can see it. My prediction is that the full article will be talking about the problem with looking at star formation at an individual level when stars usually form in groups, because they interact with each other while forming. Now we need to wait and see if I'm right. And through the magic of editing, you don't need to wait at all. I was partly right. The article was about how frequent star formation was in the early universe compared to what it is now. Star formation rates, according to this article, peaked around 7 billion years ago and have been in a slow decline ever since. A better quote, in my opinion, is the very next sentence from Simon White of the Max Planck Institute for Astrophysics. The simple recipes and published models do not reproduce the star formation we see. Theorists are now having to grow up. In other words, our current models for individual star formation fail to explain the incredible rate at which stars formed 7 billion years ago, and keep in mind we can watch this happening by observing objects that are 7 billion light years away, so this is the result of direct observation, the creationist's favorite type of science. This is perfectly in line with other articles I have read while researching this topic. One common criticism of star formation theory in the scientific community is that it only looks at isolated individual stars, when stars usually form in groups and interact with each other and other astronomical objects while they form.
Folks, the only thing we can conclude here is the universe cannot be infinite number of years old. It had to have a beginning, or it would simply be out of energy.
You sure do like your false dichotomies. What if the universe itself were infinite, but somehow became infused with all this energy somewhere in the middle of its infinite existence? You could even say it was God what done did the infusin'. But I suppose the problem with that is that it doesn't really match up with Genesis then.
Now, we've looked at the idea of infinity. We've looked at the second law of thermodynamics. Now let's look at the law of cause and effect.
I was curious to see if the law of cause and effect was actually a scientific thing, so I googled it. All I could find were wooey pages trying to teach you how to use the law of cause and effect to get whatever you want in life by thinking positively about it, or some nonsense like that. So, not an actual scientific law then.
Now, the law of cause and effect teaches this.
Any life situation can be changed by altering our perspective. Oh wait, that was from the woo-peddling Peter Baxa, who has apparently been intentionally manifesting material and personal life experiences since he was a young boy. Do go on.
Yes. Everything that has a beginning has a cause. Now notice that. Everything that has a beginning must have a cause.
Oh, I see what you're doing, setting up that special pleading early on. Also, the way you word that means the same exception which you're going to use on God could be applied to the universe. Just say, oh, it didn't have a beginning, therefore doesn't need a cause.
Also, it teaches every material effect must have an adequate cause that existed before the effect. Also, every single effect first had a cause that can be traced to a previous effect from another cause and eventually back to a first cause.
So every effect must have a cause, and every cause is the result of an effect from a previous cause, until suddenly, without explanation, you stop at the first cause. Now, are you going to explain why that cause gets to be the first one and therefore doesn't need to have a previous cause before it? Or is this where the special pleading comes in, where you just say that this one thing had no beginning, so needed no cause, but you don't actually explain why or how this thing could possibly have no beginning when everything else needs a beginning?
In other words, the universe therefore requires a cause more powerful than itself.
And that cause needs to have a previous effect that had a previous cause that was even greater than the effect. And that must be God, right? But again, I ask, why do you get to just stop there? Doesn't God need a cause that is more powerful than himself? Oh, but God didn't have a beginning. Well, maybe the universe didn't either.
Well, we do have some scientists out there that try and deny cause and effect, even though it is a well-established law of science.
A well-established law of science that can't be found with the Googling of its name. Do you know what the first result is when I search for the law of gravity? An equation that is known as the law of gravity. How about the law of conservation of mass? I get a brief summary of how mass in a closed system can neither be created nor destroyed by chemical reactions or physical transformations. Now, if I search for the law of cause and effect, the first result is some woo-peddling nonsense page that has the law of cause and effect listed as being Newton's second law of motion. I've never seen a scientific source name Newton's second law the law of cause and effect. So are you about to make the argument from motion here? The super simplified version of the argument from motion states that everything is moved by something else, so something had to set everything into motion, the prime mover. This runs into the same problem as your first cause argument. If everything needs something else to move it, then why does God get an exception? Should not God also require a mover? Also, how do you know that rest was the default state of the universe, ignoring the quantum state of the universe in its tiny dot form for the moment, as quantum mechanics often befuddle our big people physics, which is why Ant-Man was taking such a risk when he went down to the quantum level? Newton's first law states that an object in motion will stay in motion unless acted upon by an external force. Maybe the universe's default state was a state of motion, not rest. Then it would stay in motion, as it is, until acted on by an external force.
Some physicists assert that quantum mechanics violates this law of cause and effect.
Possibly. Quantum mechanics are weird. My favorite quote about quantum mechanics is from Richard Feynman, where he said, "If you think you understand quantum mechanics, you don't understand quantum mechanics."
And the principle can produce something from nothing. That's what they're telling us. I've seen this on national TV. We get these physicists out there saying, oh, nothing can create something. It's happening all the time.
Well, that depends on your definition of nothing. If you just mean the void of space, that's not actually nothing, and there will be quantum particles popping in and out of existence seemingly randomly.
For example, Dr. Paul Davies, a physicist, writes, space-time could appear out of nothingness as a result of a quantum transition. Particles can appear out of nothing without specific causation. Yet the world of quantum mechanics routinely produces something out of nothing.
Now, that quote didn't jive very well with where you cut it up, but I'll let that slide as it basically proves my point. Quantum mechanics are weird, and particles can show up from nothing. And that's from the 80s, so it's not like this is a new discovery.
Well, what are we to say about that? Well, theories that the universe is a quantum fluctuation producing something out of nothing presupposes there was something there to fluctuate. See, they don't talk about that.
Wait, so you're saying that when Dr. Davies said spacetime could appear out of nothingness as a result of a quantum transition, what he meant that there was actually something there that he's not mentioning? If he said that, you cut it out. And I'm sorry, but you, a mathematician by education, bringing up infantile points like that as if a quantum physicist had never thought of it, is insulting to your audience's intelligence. You also seem to have forgotten the part where he said it could happen without specific causation, no first cause needed.
However, you see, their quantum vacuum is a lot of matter, antimatter potential, not nothing.
And what's your source on that? My looking into the quantum explanations for the origin of the universe suggests that if we were to travel back in time to the very beginning, we would reach a time when time itself gives way to space, so that there would be space but no time. Since space existed but not time, the idea of a beginning is meaningless because the concept of a beginning relies on the existence of time. According to this proposal known as the hartle-hawking state, the universe had no beginning, but is not eternal. None of this is intuitive because we evolved to understand how things work in a very specific and tiny region of the universe. This is one of the many places where common sense doesn't match up with science, and there's no reason we would expect it to, as our common sense evolved out on the African plains. See a link below for more details on science versus common sense.
If the universe had no cause, then it can't have any properties to explain its extraordinary ability to call itself into existence by itself.
But if the hartle-hawking state is correct, then that is entirely unnecessary.
Because it wouldn't have any properties until it actually came into existence.
Exactly. And the mass existed before the time did. Time came into existence with the Big Bang. Physical properties were always there, for whatever always can mean in this case. We don't really have the words to describe what it would have been like before time, but that doesn't mean that there was nothing before time, just because our language is limited.
Therefore, options 1 and 2, option 1 being the universe created itself, and option 2, the universe has always existed, cannot be true unless we simply do not want to believe in science and logic.
So the options that are the most accepted by people in the scientific community cannot be believed if we want to accept science? That makes no sense. Now, he spends the rest of the video asserting that a god must have done it and saying that the rules he laid out for the universe don't apply to God because reasons. So special pleading accompanied by Bible verses that claim God created everything. So video number 1, how much evidence has been given for God? None. In a best-case scenario, if everything Mike said was completely 100% accurate, the most that could be said is that he gave evidence suggesting that our current scientific theories about star formation and the beginnings of the universe need refining. And guess what? They do need refining. But saying God did it, so stop looking won't accomplish that. That's all for today. Thanks for watching. Remember to follow me on Twitter and Facebook and support me on Patreon. See you next time.